So here we start Thermo number 10, and now that we've been introduced to Gibbs free energy and looked at it a little bit qualitatively, we're going to start to get into some calculations here. And just like with enthalpy, there's several ways you can do this. We've looked at this equation. We've got the delta G equals delta H minus T delta S. So if you have temperature, entropy change, and enthalpy change, really simple to plug those in and get delta G. Just like with entropy and enthalpy, we've got the products minus reactants, so that'll give us the change. Just like with enthalpy, Hess's law can be applied, so take a whole bunch of reactions that can be combined to make the one you're looking for. And then there's three new things on topics we haven't covered yet. These are going to go into the last video. And what's going to be a little tricky with these is equilibrium and electrochemical reactions we haven't covered. So you need to know a little bit about these at this point, but you need to know that more is coming. So you can be asked questions about this on this test because we can look at it qualitatively. We can tie things like the equilibrium constant, or excuse me, the voltage of an electrochemical cell, that E or that K, to the sign on delta G. But the exact calculations aren't something you can expect to be doing a lot. So the first way to calculate delta G is by knowing the enthalpy and entropy. Sometimes you're just given a delta H and a delta S and you have to use them, but very often you are going to have to do something to calculate them. So this is a really good multi-step AP question, like it says, and some things here is that I didn't write it up here, but remember, kilojoules, and joules as our units, and it has that down here. So if we think about what these mean for a second, the reason that these two are negative values is that the bonded atoms are more stable than the separate sulfur and oxygen. The reason O2 is 0 is that it's an element in its standard state. All three species, and that's a word they like to use at the College Board instead of calling them reactants or products or substance, all three species have values for entropy because none of them are a pure crystalline solid at absolute zero. The lowest entropy goes to the least complex molecule. And then as we go more complex by adding in more atoms and therefore more electrons, the entropy increases. So before we can get to the delta G is delta H minus T delta S, we have to find out what delta H and what delta T are. But very simple calculations that will just review things we've already done. So let's zoom in, find some space to do those over here off to the side. So delta H is products minus reactants. So let's see. 2 times negative 396 minus 2 times negative 292. Scoot just a bit. And even though oxygen's 0, I'm going to put it in there, and then I'll get to my answer. I believe I have negative 198. It's very important in these sort of problems to keep track of your units, so remind yourselves that the delta H is going to be kilojoules. So we've got our delta H, delta S, very similar calculation, except we actually do have a value for oxygen. But here we're at 2 times 257 for our product, minus 2 times 248, plus 205. And that gives us negative 187. Make a little space to remind ourselves of the unit here as joules. So we've got a kilojoules and a joule. So we either need to change both to joules or both to kilojoules. I'm going to go both to joules. So we have done these first two calculations, the delta H and the delta S, and we have those correct. Oops, I forgot. Both of these are probably kilojoules per mole reaction, but that is joules per Kelvin. That's an easy thing for me to forget. Don't know why, but don't forget it yourself, especially since it's got the units right up here, the kilojoules per mole and kilojoules per mole Kelvin. So then we just need some space to finish out delta G. I didn't leave myself very much, but if I zoom way in, I've got all the space I need here. So delta G is what we're looking for. We know delta H is negative 198. Minus T, which is 298, that's my temperature in Kelvin, times negative 0.187. So I changed that one to kilojoules. Both are in kilojoules. We've got something that's exothermic favorable, something that decreases entropy unfavorable, so the negative with the negative means it ends up positive overall, but still, excuse me, not positive overall. This term is positive overall. Overall, we have negative 142 kilojoules per mole reaction. And when you're looking at that, this is an instance where if this temperature were high enough, and it'd have to be really, really high, that negative value could be overtaken by the decrease in entropy. So we could calculate what temperature that occurs at, but it'd be a very, very high temperature, because if you look at this, this right here is more than 10 times, more than 100 times, more than 1,000 times bigger. So this temperature would have to be more than 1,000, but definitely a possibility. So that's where the 142 comes from, and the delta G is kind of small by the time I got it all on there, but you got the idea. Very simple. And now looking back, I'm seeing that I put delta H there. This was the S, and hopefully that wasn't too confusing. The second way to do this is standard values. We've already done this 2 times. We've done this with entropy. We've done this with enthalpy. So hopefully you're not going to be surprised when it's the exact same thing right here. So delta G, it would be 2 times negative 27.2 minus 2 times negative 56.7 equals, and then we get that. So this one was as quick as can be. What I didn't show in there was we do have a +0 term. It's always good to show that, but if you skipped over it, you would not lose any points because it doesn't change your answer and it doesn't change the work. You're just showing that you understand the fact that there's no value here for this means that it doesn't affect the reaction. I would probably say to put it in there. Obviously, I didn't. The other thing I wanted to point out here was that this is kilocalories, which gave this answer in kilocalories, just another unit. There's lots of different units that can be used. Pay attention to units, make sure your answer has the right units. A lot of times in a problem it tells you what the preferred units are, so be doing that and using those things. Then we have Hess's law to finish up, and it's the same thing we were doing when we were doing this with enthalpy. We've got given reactions, we have to play with them, turn them around, double them, triple them, keep them the same, do whatever it takes so that the reactions given add up to the reaction we're looking for. And this is one we talked about way back when we were talking about what it means to be spontaneous. It means that it'll occur without outside intervention, it'll occur on its own, but hopefully this will occur very, very slowly. So we have graphite and oxygen making CO2, or diamond or oxygen making CO2. Overall a very similar reaction, but a little bit difference there in terms of delta G. So to put these together, I'm going to zoom in just a little bit. Hopefully keep everything. There we go. So then I'm going to keep the diamond one, so I'm just going to call that diamond. Plus O2 makes CO2. That stays as is, so the delta G is the negative 397. I need graphite on the product side, however, so I'm going to look at the reverse of this. CO2 makes graphite plus O2. The delta G there is positive 394 because I ended up reversing this one. Reverse. So then I'll double check that everything cancels. 1 CO2, 1 CO2, 1 oxygen, 1 oxygen. I'm left with diamond. I'm left with graphite. And when I combine these two things, the difference is just that 3 kilojoules per mole reaction. So the same thing, in this case, 2 very simple reactions, very little to do with them. Great as a one-point part where then you would go on, maybe there's a kinetics part, maybe there's more thermo stuff, maybe there's even equilibrium or something else going on with this. But an easy point to pick up. So you want to make sure no matter what the calculation, the 3 we did right now or the 3 you'll see in the next video, that you have all of those skills in your arsenal.